Hi guys, welcome back to another video. Today we're going to be looking at the AMC 2017 problem number 19. And here's a quick read of the problem. So for any positive integer m, the notation m exclamation point, which we read as factorial, denotes the product of the integers from 1 up to m. And the question is, what is the largest integer n for which 5 to the power n is a factor of the sum 98 factorial plus 99 factorial plus 100 factorial? And so for this question, obviously 98 factorial, 99 factorial, and 100 factorial are all way too large to calculate, right? Because just to make sure we understand factorials, 98 factorial represents 1 times 2 times 3 times 4 all the way to 98. So obviously we're not going to sit here and calculate this. So there has to be a faster way, right? 99 factorial is the same thing all the way to 98 times 99. And then for 100 factorial, we have the same thing, but then we have an extra times 100. So it'd be 98 times 99 times 100. So with this question, right, what we want to do is look at some way where we could express the sum in a more simpler way so that we're not forced to multiply these numbers out. And so when we're adding these, you might notice that there's a lot of common terms, right? This 98 factorial shows up in each of our terms, right? So we have some extra some extra numbers that are being multiplied afterwards, but we start off with 1 through 98. So what we could do is, if we were adding these up, we could actually factor this out, right? So 98 factorial, that would just be a 1, right? 98 factorial times 1 is just 98 factorial. When you factor out 98 factorial from 99, you're left with just 99, right? It's just this right here. And then from 100 factorial, you have 99 and 100 that are left over. So you have 99 times 100, right? And we want to find the largest integer n so that 5 to the n is a factor of this. So they're basically asking us to find how many 5s divide this evenly. And now, okay, so if we can simplify the inside of this parentheses. This isn't too hard to do. 1 plus 99 is 100. So then 100 plus 9900 is just equal to 10,000, right? So then we basically have 98 factorial times 10,000. And this, we want to find how many 5s fit into 98 factorial times 10,000. And so the 10,000 part is easy, right? 10,000 we know is just 5 to the 4th times 2 to the 4th, right? So that's easy. We have 5 to the 4th in 10,000. The hard part is figuring out how many 5s divide 98 factorial. And to do this, we use something called Legendre's formula. And it seems complicated, but basically what it is when we do 98 divided by 5, right, and we take what's called the floor function, right? So the floor function, just as a quick reminder, is when you perform division or anything and you take the smallest integer less than your division. So 98 divided by 5, that comes out to 19.6. So the floor of 19.6 is 19. Right, so this means there's 19 multiples of 5 less than 98. And we kind of list this out and you'd see 5, 10, 15, 20, all the way to 95. There's 19 multiples of 5 here, right? And because we're multiplying all of the numbers up to 98, these are all these multiples of 5, we're multiplying by each other. So we have at least 5 to the 19th here, right? So you might think, okay, we're done. But no, the thing is, if you take a number like 25, 25 is 5 squared. So it actually contributes 2 5s to our total product, right? We counted 25 once right here. We have 20 and there's a 25 over here. So we counted the 5 and 25 once, but we want to add another one for the extra 5 because there's 2 5s in 25, right? And similarly, 50 is our next multiple of 25. This is another one that has 2 factors of 5, and we only counted once. And then 75. This is 5 squared times 3. So this again has an extra factor of 5. So this is an additional 3 factors of 5 that we need to account for. And so Legendre's formula, it's the same thing as this, just written more concisely. It just says you take your number 98 and I divide it by 5. And then I take the floor. Then I take 98 and then I divide it by the next power of 5, which is 25. And then I take the floor of that. And then I keep going with the powers of 5. But you might notice, after 25, the next term is 98 over 125. This is less than 1, right? 90 divided by 125 is smaller than 1, which means the floor function of this is actually 0. So anything after this we can kind of ignore. And as you can see, 98 divided by 5, we know is 19 when you take the floor. 98 divided by 25 is 3 point something, so the floor is 3. And again, that's here 3 that we found over here. So this means we have a total of 22 factors of 5 in 98 factorial. And so we're almost done, but we just want to make sure we don't forget the original 5 to the 4th up here that we found, right? If I boxed in red, right here. So this basically just means that in 98 factorial, let's just move over. So in 98 factorial, we have a total of 22 5s. And then in 10,000, we have 4 more 5s. So that means when we were to multiply 98 factorial times 1000, all we have to do is add this number together. 22 plus 4 is just 26. And that would be our final answer. And so when we look back at the question, they're asking for the largest integer n, for which 5 to the n is a factor. We found that there are 26 powers of 5 that go into this sum. So our answer would be n equals 26. And we'd be done. So that is going to bring us to the end of this problem. If you have any questions, feel free to leave a comment. Otherwise, like and subscribe so you don't miss out on any future uploads. Thanks to everyone for watching, and we'll be back again tomorrow with another question.